Hello, welcome to Coding on Crack. Today we're going to look at how to run image classification models locally on your device in Swift using CoreML for iOS apps. We're going to cover four main topics today. First is how to generate and annotate your data set. Second is how to train a ResNet model using transfer learning. Third is how to export that model in the CoreML framework format. That way you can, number four, run it locally on your iOS device. We're using ResNet because it's a pre-built architecture that works very well for many different types of tasks. It's intended to be used in a transfer learning context, and it maintains good accuracy while being fast and small, just like me. So we then want to export that in the CoreML format, because by putting it into that format, we're able to run it locally on our device, which means we don't have to set up a cloud service that runs our ML models. So then we aren't paying compute costs. We have much lower latency when running inference. The actual model deployment process becomes substantially easier, and we're actually able to do a live feed inference instead of having to wait for our image to go to the server, the processing to happen, and then for it to come back. So let's jump into the code so that you can see how this works, how you can move through this pipeline as quickly as possible so you can get your penis image classification model into your app, or whatever else you're using it for, and move on with your life. All right, step one is to get your data set so that you can actually train your model. First, we're gonna hop into RoboFlow, is what I use to annotate my data sets. You could also use something like Label Studio, and there are many other options out there, but RoboFlow, free, online, super easy to use. So come over here, create an account, all this bullshit, hit new project. Let's call this project classification, and the groups, let's say dogs and cats, and create a classification project. Create public project. It's public because I'm on the free version. I've got my bullshit data over here that I snagged off the internet, and I'm gonna freaking throw that stuff in here, and it's gonna upload these files. Then I'm going to label my data. So I'll come in here, label myself, and I'll be like, geez, what the hell is this thing? Well, that's a cat. And then I'm gonna not do caps lock. I'm gonna call that guy a cat. I'm gonna call then this guy is a fucking dog. This guy is a dog, and then you can go next, and you say this guy is a cat, and then you can go next, and then you say this guy is a cat, and you can go next, and you say this guy's a freaking dog, and you go that, and then you can add everything to the data set. It adds them all at once, and then bada bing, bada bang, we're fucking chilling. And then when you come to your actual versions, you're going to do your pre-processing, whatever you want those to be. I would recommend 240, I believe, by 240 tends to be a good go-to. Hit apply, and then hit continue. You can do some augmentation steps. These are always good to have. So maybe do a little augmentation step. Let's like flip one of these bad boys, and then do another one. We could do a 90% rotate, bada bing, bada bang, create. This is a version, okay, and then we hit create. And then here we go, it's initializing our version, and now we've got a data set. The next thing you're gonna wanna do is one of two things. Given the way that I've set up step two, we're gonna hit download dataset, and we're going to download a zip to our computer. Now going forward, I'm gonna use a different data set that somebody else put together that's much more expansive, so we can have a little cool project at the end. But this is essentially what you're going to do with your data set. Then you hit continue and download, but geez, I don't want it to download. Okay, so let's go on to step two, because now you've got your data set downloaded and on your computer. A quick note before we move on, you want to, however you are getting your data set, whether you use RoboFlow or some other bullshit, ultimately what you're looking for is this folder structure. You need to have your data set name. So in our case, that's going to be Pokedex V14 Pokedex resize.folder.zip. And then inside of that, if I were to unzip that, you would see essentially three subfolders: train, valid, and test. Within each of those subfolders, you'll have each class. So in my previous example, you'd have, dog and cat. And then within each of those, you'd have each of those images. In this example that we're actually going to use, it would be, all of the Pokemans and the actual images of each Pokemon. So now let's move on and actually train this bad boy. All right, now you got your data set. Now you got to get on this. I'm gonna have a link to this Google Notebook down below so that you can just use my code instead of trying to rewrite it all. Because honestly, this shit was a bitch to write. It took so much time. There's so many problems. And if you do run into any problems, please leave a comment and then I can hop in there, get it fixed up. But let's look at this. So first thing you're going to do is just run every cell back to back. But before you do that, so that's not the first thing you're going to do. The first thing you're going to do is come into your downloads file or folder, grab that .zip file of all of your data, and you're going to put it into Google. The reason you want to use a .zip is because if you try to upload a folder, it's going to take ages and it sucks. And we don't got patience for that shit. So you grab your .zip, you throw it in here, you copy the path, you come to cell 1, 2, 3, and you paste the path to your zip folder right here. Super easy, super chill. Then you're going to run this cell, run this cell, run this cell, and then you're going to set up your config. So in this case, what we're doing is we are using a file. If you were to use RoboFlow's code download, which is an option if you know what you're doing, then there's the option for you to do that as well. And you can change that option right here. But for now, you should probably just do it locally. Locally is better, in my opinion. So come in here, local data root. This you're going to keep as the same because we are renaming our unzipped data set as a data set folder. That's going to be this. You're going to choose the model that you want to use. In our case, we're using Resnet50, but if you need something more powerful, then you can go with Resnet101. And then our image input size is 224. I guess I messed up before. I was using 240. If you put 240, you can type in 240 right here. But in our case, or in my case, it's 224. Whatever your image input size is, use that. I would also recommend using 224. Image batch size, most of these you don't really need to worry about changing. Learning rate, 1 e to the negative 4 is cool. If you know what any of these things are, then you come in and change them up. The next thing you're going to do, run this guy, make sure that all of your imports worked, and then go into function definitions. Just run the cell that's going to activate all of the functions, make them all available. And then when you come down to run pipeline, you'll essentially be totally set up to just hit Command Shift Enter or Command Enter Shift Enter, whatever the hell you do. You're going to run this cell, and that's going to train your model. Now it uses this thing called early stopping, where it essentially keeps track of how much the model improves between each epoch, training epoch, and once it is not improving very much, then it's going to just stop the training. So instead of going through 30 rounds of training, you're only going to go through 18, which is pretty nice. And then right here, you can see your outputs, you can see your loss over epochs, your accuracy over epochs, and your overall metrics. And that's going to then automatically convert your TensorFlow model into a CoreML package. So that's the great thing about this code. Go into the description, use this code. You don't even have to know how the hell it works, but if you really want to know, you can come up here, and essentially most of the magic is happening in this export CoreML function. That's essentially where it's going to rebuild the model, run some data through that model, and then export it in that ML package format. And then when you come down to the very bottom, you're going to create a zip file and download your artifacts, where your artifacts are essentially going to contain everything that you need. So it's going to have your confusion matrix. This is a massive confusion matrix, so not very useful, but that's okay. All of your class labels. It's going to contain the H5 file for your best model. It's also going to contain the history of all of your previous models, and then it's going to actually have your .ml package, and it also exports the Keras model as well. All right, so now that you have all of these artifacts, you're going to grab your image class resnet.ml package and drop it into the whatever project you're working on, copy files to destination, and hit finish. Once it's in here, you can fill things out like the description. You can do versioning in here, and I would happily make another video about ML model versioning, how you can iterate iterate, create better models, and track their performance over time and create a pipeline to do so. You can look at your predictions. This is going to show you your input is a color image, 224 by 224 pixels. Your output is two outputs, actually. You have your class label, which is essentially the prediction that the ML model made, and then your class label probs, which is basically just the probability of each class label available to the model based on your input. And here you can create a performance report to see how well it works on different devices. And in this structure, you can actually see the ResNet ML model architecture kind of like laid out for you. So at the beginning, we have our input, and then in here we can see our convolutional layers, inputs to that ReLU activation function right here. All the way at the end, we have our outputs, that class label, and those probabilities. And then here you can do model encryption. Now, I'm not going to run through all the details of how Core ML works or how you set these things up in the app. I think that would be better as a video of its own, where I will go through all of the kind of the details of how to actually run inference on these ML models. But I'll quickly go over essentially what's going on in here. So we have our inference service. This is a singleton. So we have a single instance of our inference service shared throughout all the apps, so it's accessible from anywhere. The advantage of this is that you only initialize your model once, and model initialization can be a somewhat hefty task. This is our vision model. This allows us to, put our image inputs in and get our prediction outputs out. In this initializer, we just set up a default config, tell the computer that it can use, or the device that it should use whatever compute unit is optimal, such as like a CPU or a GPU. That's your processing unit. Then down here, we are actually grabbing this ML model with the default configuration or with this configuration. This image ResNet, image class ResNet, that name aligns with this image class ResNet. If you command click on it, you can see this is all of the code that XCode automatically generated for you when you drag and drop your .ml package into XCode. Then, if we go back to the inference service, we initialize it, we wrap it in a VN Core ML model. I can go more in depth on this elsewhere, but essentially this is just a wrapper class around a traditional ML model to make it better for doing or easier to do vision-oriented tasks with that model. Then I just output some stuff. Here we're crashing the app if we fail to load the ML model, because if our app doesn't have an ML model, or if it doesn't work, then the whole app doesn't work. And then down here, we are essentially defining a classification function. It takes in a UI image, and then it's going to run classification on that image, or run inference on that image using that ResNet ML model. It's going to run that locally because we export it as a .ml package. So that's kind of the magic that we get here from exporting this ResNet model as a .ml package. We don't have to do any asynchronous operations. Then we're essentially just returning the model's primary prediction, the output that it most expects. That's essentially, we're essentially just outputting this class label. Then in our content view, this is just a little example app that I put together to show you this happening. We have this button, run ML inference down here, classify image. We access that inference service, shared instance, and we run the classify function on our selected image. In this case, it is Pikachu. And then if that fails, we're going to throw an error. Otherwise, we're just going to create a little string and show that in the UI, showing the result that came from the classification. That output is going to include the identifier. The identifier is basically just the class name of the predicted class, and the result .confidence is how likely or how sure the model is that that class name is what that image is. So if we hit run inference, it says it's 87% sure sure that Pikachu is what is being showed in this image, and that is true. If we get rid of this guy and we show this guy and we hit run ML inference, then, oh, I gotta wait for the content view to reload. We have our Charizard input image, run ML image. It's 97% positive that this is an image of Charizard, which it is correct about that. Anyway, thank you so much for watching. Like, subscribe, comment. Let me know if there's anything that you would want to learn more about. If you'd want to learn more about model versioning, if you want me to go more in depth on how this export script actually works and how it converts ResNet into Core ML. But realistically, that should be set up so that you guys can just run it. And of course, if you do have any problems with it, put those in the comments as well. And yeah, at some point I will make another video where we look more in depth at Core ML and how these actual functions work. Anyway, thank you. Have a good day. Bye-bye.